Okay, so this tutorial is going to take you through some advanced character setup. Um, at the moment, I have got a very basic setup here, which was taken from the main, which was the very first tutorial about how to set your game up in Python. The only change I've made is I've changed the background to white rather than what it was before. So that otherwise, there's nothing else in here that should be confusing. So to prep for this one, I've created another folder here called sprites, and I've added a PNG file for my character in there. We're not going to be doing any animation in this tutorial. It's just about how to set this up using a more object-oriented programming way compared to the more basic setup that we did last time. So first thing I'm going to do is I'm going to create a new file, new Python file, and I want to call this game character. Okay, now in here we're going to create a class game character, and we are going to what's called inherit from Pygame sprite class. Now, because we're using Pygame, we are going to need to import Pygame at the top of this class as well. Now, just to quickly go over what's going on here, this is the name of the design I'm creating. This here is taking on a design that already exists in Pygame. So in Pygame, there's already a class that's called a sprite class, and that has a lot of features that have already been pre-programmed, which is one of the advantages of using a game engine. So the idea here is that we're going to import all of the abilities of a sprite that's already been programmed in Pygame, and then we're going to add on our own additional changes to that. So the first method we have to create when we're building a class, or most of the time, will be a constructor. So you think of the class as the blueprint, it's the design for a game character. The constructor is the first method that's called when we actually build one of those characters. So it's the first piece of code that runs when one of these is created. Now in Python, it's quite unusual. The setup, it's a double underscore followed by init for initiate. And then we tend to always have to have self in here, which I'll explain as we go along why that is. Now, when we create a game character, we have to think, okay, we want this to be as flexible as possible. So maybe we want the image not always to be the same. So when we create one, we're going to send a variable which will contain the image path for the file that it should use. We're going to take coordinates, an X and Y coordinate for the position we're going to draw it at. And we're going to have another variable that would determine the size of the character that we're going to draw. This just means that this class becomes a lot more flexible. We can potentially use it for more than one character in our game, rather than it being super specific for just one game character. Excuse me. After that, we're going to call super, which basically what this does is it calls the constructor of the sprite class. So when we create a game character, because this is inheriting from here, the first thing we need to do is create the sprite. And this is what this line of code does here. The super references this class here. This is called the parent class, and this is the child class, and the super being the class above this one. So the first thing we're going to do is deal with the image on the character. Now you notice I've put self. So these variables would exist for each of the objects that we create. They're called instance variables, and we refer to them as self all the time. If I don't put self, basically all I'm doing is creating a variable that exists just within this method, whereas these variables with self are going to exist in any other method I use in the class, which makes it very easy for me to get access to them. So we're going to create an image for our character, and we're going to use the image path that was given to us when the character was created. After that, we are going to resize the image. So we're going to transform it, and scale it. What do we want to change? We want to change what the image is at the moment, and we're going to change it to the size that again was given to us when we created the object. The next bit is an optional bit. Now, I noticed on my character, he has a white background. So I thought it'd be a good opportunity to show you, if you do have a situation like this and it's not transparent already, you can use a built-in method in Pygame where we can tell the image to convert alpha, which will mean the white will then become transparent. And then we need to get a rectangle from around the image, which allows us then to place the image on the screen and move the image around. So we've created the rectangle, and we're going to then set that, the top left of the rectangle, to be at the position that was given to us when the image was created, when the object was created. So that's the construction. This just builds the character. Then as the game's being played, we will generally run this update function every single time the game updates. All of the objects in the game will run their update function to maybe move them around, check for a collision, and just update everything on the game before we then flip the screen and re-update the display. So in the update, I'm going to receive two variables, two parameters here. The first one is, are we going to shift the X coordinate at all? And then the second one, are we going to shift the Y coordinate at all? In other words, we're going to move the character along. Now, the reason I put equals 0 here is because this is a default value. If I don't send it an X shift, then by default, it will assume that I don't want to move on the X axis. So we then adjust. So this is an example of where I was talking about where we're using self dot, and it gives me access to any of these variables here. So I don't have to kind of pass them. They exist across all methods for this object. And then we're going to shift it by whatever was given to us. So we'll move it along the x-axis or move it along the y-axis. Okay, so that's the basic setup for the character itself. But this is, as I said, just a design. We need to now go back to our game, and we need to now make one of these characters using this design. So let's make a character. So this is what I'm going to call him in the game. He is going to be a game character. And then I need to pass all that information that I said was required for me to create one. So the first thing is an image, then a position, then a size. So the image is going to be a string. I'm going to pass it sprites character.png. And the reason it's not giving me any help here is it still doesn't recognize this. One of the things I haven't got is this. So I want to go to this file and I want to import this class from the file. So it should give me a little bit more information now as I'm going through. So the second piece of information I need to send it is the position and then the size. So position, let's say, is at 100 pixels in from the left and 100 pixels down from the top. And then the size, let's set that to 50. Now here we go. Now it's starting to feed me this information. So we've created an object now from that design. This is the character that has been created. Now we want to try and keep track of all our characters in Pygame. So we're going to add this into what's called a Pygame group. It's always good to have at least one group that contains all sprites in your game. And then as you get to more complicated things, you might have separate groups for different categories. So you might have a group of enemies, a group for the bullets, a group for the player. Okay, but in this instance, we're just going to have one group that's going to contain everything. And in that group, we're going to add a character to it. Now, the reason why groups are quite useful is because when it comes down to updating, we can call the function. So we can say all sprites update, which will run this function on all of our sprites across our game. Okay, and then after that, once they've all been updated, we can draw them to the screen of our code. So let's just run this initially. Okay, looks like we've got an error here. Okay, so size must be 2 numbers. I think I only passed it 1 here, yeah. So we're probably getting a height and a width that's required. So passing it again as a tuple. Let's try. Okay, so on this one, again, it didn't like it. We got our position here. Let me just pause this for a second and work out what's gone wrong. Okay, so I realized my mistake here. This here is actually a property of the rectangle. It's not a function. So we shouldn't have brackets here. We just set the top left position to equal this, and that should be better. Okay. So there we go. We got the character. He's a little bit small at the moment. Let's come back in here and rescale this a little bit. So you can see as it stands, it's allowed me to kind of stretch, and I haven't managed to keep the dimensions. If I have a look at my picture, it's actually 800 by 600. So I should scale these the same way. So for example, if I was to reduce this by half, it would be 400, and then 300 would make more sense on this. So I think actually 200 and 150 would keep the correct dimensions of the image. That looks better. Okay, so remember on the update, we said we did have a potential to pass information. So on here, I had an X shift and a Y shift. So if I send it one of the so I've basically set one of the potential variables now to 5, and then run this again, we should see the character move across the screen. Now, if you've got, if you've already gone through the character control, which you should have by the time you've got here, you would then apply this same logic, possibly to a move function rather than an update. So I would have a def move where I would bring these in, and then if I press the keys, I would shift it by the amount I wanted on the X or Y axis when that key is pressed. But hopefully that's clear without me running that through another tutorial. Okay, so that's your more advanced character setup. We were looking at adding more features to this in future videos.